Hello everyone, we are from Group 6 and we would like to explain about validity, reliability, and testing of assumptions. But before that, let us introduce ourselves. We are from English Study Program in Faculty of Teacher Training and Education in Sriwijaya University.
Faculty of Teacher Training and Education is one of faculties at Sriwijaya University. This faculty offers one of the biggest number of academic programs and student body among other faculties. The faculty has participated in numerous activities and obtained many achievements, both in national and international events. On the 1st of October 1958, the Palembang State English B1 course was founded, marking the beginning of the history of this faculty.
The lecturer for this course is Dr. Ismail Petrus, MA, and here are our group members. We have Amelia Yosanda, Anissa Salsabila, Dimas Nugraha, Muhammad Rusli, Nito Septian Putra, and Shafina Shahla. Here's the table of content of our explanation today. First, we will explain about validity, and then continued with reliability, testing of assumptions, normality, homogeneity, and lastly, linearity. Without any further ado, here is our explanation.
Alright, I will explain about validity. In simple terms, validity refers to how well an instrument or method measure what is it intended or supposed to be measured. Validity shows how a specific test is suitable for a particular situation. The focus of validity is to check whether the given instrument or method has the potential to measure what we want to measure. So what is measure? Measure are the items in a research study to which the part responds. Research measure includes survey question, interview question, or constructed situation. If a test claims to measure speaking proficiency, then the test should measure the ability to speak. An instrument is said to be valid if it can reveal the data of the variable to be studied. One of the alternatives to test validity is using Pearson product. Pearson product moment correlation coefficient by correlating each item score with total scores. There are two alternatives in making decision in validity tests. One, seeing the value of significance. A. If the significance value is under 1005, the instrument is declared valid. If the significant value is 1.05, the instrument is declared invalid. 2. Comparing the critical value of R table. A. If the obtained value is under the critical value of R table, the instrument is declared invalid. B. If the obtained value is the critical value of R table, the instrument is declared valid.
Reliability is defined as the extent to which the instrument's result can be considered consistent or stable. It indicates the degree to which the measurement is free from errors and fluctuations. The degree to which a task is considered consistent or reliable can be estimated by calculating a reliability coefficient. The reliability coefficient can go as low as 0 and as high as 1. Another alternative for this is by using Cronbach's alpha. Cronbach's alpha has the rule of thumb that is reliability should be at least 0.7 and preferably higher. Look at the example in the table below. As you can see, the Cronbach's alpha is 0.820. Because the value is more than 0.70, it can be concluded that the research instrument is reliable.
Testing of assumptions. In statistical analysis, parametric tests rely on certain data characteristics referred to as assumptions. The violation of these assumptions can alter research conclusion and research interpretations. Therefore, adherence to this assumption is crucial for accurate analysis, with variance depending on the specific parametric test conducted. Common data assumption in statistical research include the first one is assumption of normality. Normality means that the distribution of the data is normally distributed with a symmetric bell-shaped curve. The next one is assumption of homogeneity of variance. Homogeneity of variance means that two datasets or more have equal variances or the same distributions. The last one is assumption of linearity. So linearity means that the relationship between or among research variable is linear.
One, what is the assumption of normality? The assumption of normality is a key aspect in many statistical techniques. For example, in a one-sample test, it's assumed that the sample data is normally distributed. Similarly, in a two-sample test, it's assumed that both samples are normally distributed. In ANOVA, it's assumed that the residuals from the model are normally distributed. 2. Ways to test for normality. Box plot. Draw a box plot of your data. If your data comes from a normal distribution, the box will be symmetrical with the mean and the median in the center. If the data meets the assumption of normality, there should also be few outliers. Normal probability plot. This is another graphical method for assessing normality. Descriptive statistic. Check descriptive statistic for sign of normality. Histogram. Generate a histogram to visually assess the distribution of your data. Chi-square test. This is a numerical method for testing normality. 3. Importance of normality in parametric testing. An assessment of the normality of data is a prerequisite for many statistical tests because normal data is an underlying assumption in parametric testing. 4. Dealing with non-normal data. It's also important to know how to handle situations where your data fails the assumption of normality. 5. Normality in statistical research. Most of the parametric tests require that the assumption of normality be made. Normality means that the distribution of the test is normally distributed, or bell-shaped, with zero mean, with one standard deviation and a symmetric bell-shaped curve.
Testing of assumption, homogeneity. So what is homogeneity? Homogeneity is a statistical assumption that needs to be met in certain types of statistical tests, such as analysis of variance or ANOVA. So, the assumption of homogeneity refers to the requirement that the variances of the population from which different samples are drawn should be equal. So there are two tests in homogeneity. First is Levin test. To test the assumption of homogeneity of variance, Levin test is used to assess if the groups have equal variances. This test should not be significant to meet the assumption of equality of variance. And the second one is box and test. This test is used to test the multivariate homogeneity of variance covariance matrices assumption. An insignificant value of box and test shows that those groups do not differ from each other and will meet the assumption. Violation of the homogeneity assumption can lead to be as result. Hence, it's crucial to test the assumption before proceeding with the analysis. So, testing for homogeneity. The goodness of fit test can be used to decide whether a population fits a given distribution, but it will not suffice to decide whether two populations follow the same unknown distribution. A different test called The test for homogeneity can be used to draw a conclusion about whether two populations have the same distribution. So it's important to note that the more incompatible or unequal the group sizes are in a simple one way between subjects ANOVA, the more important the assumption of homogeneity is. Unequal group sizes in factorial designs can create ambiguity in results.
Alright, I'll continue the material about linearity test. Linearity means that two variables, x and y, are related by a mathematical equation y equals cx, where c is any constant number. The importance of testing for linearity lies in the fact that many statistical methods require an assumption of linearity of data. Example, the data was sampled from a population that relates the variable of interest in a linear fashion. Linearity test is intended to determine whether the relationship between or among research variables is linear or not. Linearity test is a requirement in the correlation and linear regression analysis. When testing the assumption of linearity, it is conceptually useful to remember that the random component of the real-world phenomenon that we are interested is captured by the error term in our linearity model. This means that we want to see randomness in our residuals representing the error. This can be assessed by visually assessing the residuals in a scatter plot against the predicted values. A non-random pattern indicates a problem. For the application of linearity, the creation of a scatter plot of the residuals versus the predicted values is a simple and effective step in the diagnostic process. For example, if the seek value of deviation from linearity is more than 0.05, then the relationship is considered linear. Besides, if the seek value of deviation from linearity is less than 0.05, then the relationship is not linear.
In conclusion, validity ensures that a measurement accurately captures what it is intended to measure, while reliability refers to the consistency and stability of measurement results. While testing of assumption in statistical analysis, adherence to assumptions such as normality, homogeneity, covariance, and linearity, and it is crucial for accurate interpretation of results. Ensuring validity, reliability, and testing of assumptions are fundamental steps in conducting robust statistical analysis.